Hello everyone, my name is Douwe Ravers and I'm a researcher at Gerling in Belgium. I will be talking about the potential of interactive technologies and games in the field of wheelchair skills training, especially for children and young people. Over the past few years, we've seen a lot of exciting developments in this space. There are virtual reality simulations for powered mobility, augmented reality tools for manual wheelchair training, and even tablet-based systems that guide users through real-world exercises. However, when we're designing these technologies for kids and teens, it's not just about improving the technology. Research shows that we need to adapt to their abilities, offer positive encouragement, and help them feel more autonomous during therapy. At the same time, therapists still play a crucial role in making sure the training is both effective and safe. Now, some previous work has emphasized the importance of using clinical training protocols in these systems, but there's still a big gap. We don't yet have a clear process for how to integrate those protocols into something that's also fun and engaging like a game. And that's exactly where our work comes in. We developed a game called RollAbility. It's a therapeutic game designed specifically to support powered wheelchair skills training for children and teens. Our goal with RollAbility is to bridge the gap between clinical best practices and engaging gameplay. And in doing so, we have also been exploring the challenges that come with merging these two design domains. So, how did we go about designing this? We asked ourselves the following question. How can we design games for wheelchair skills training that follow clinical best practices while still being fun and engaging for players? To answer that, we followed a three-phase design approach. In the first phase, we focused on extracting design goals from clinical protocol. We studied how the wheelchair skills training program exercises are performed in physical therapy, and we worked closely with rehabilitation researchers to figure out how we could translate those exercises into a virtual format. We selected 6 key exercises to include based on their importance in therapy and virtual conversion feasibility. For each exercise, we identified the critical therapeutic elements for learning the skill. We also identified the required measurement criteria to correctly make performance assessments, and we identified what aspects of the exercise the therapists adjust for controlling the difficulty of the exercise. In the second phase, we built a testbed environment to simulate the exercise. This helped us redefine the core technologies through interdisciplinary discussion, like how to use powered wheelchair input as game controls, how to visually represent the exercises, practically implement the defined design goals of the first phase, and how to identify further usability improvements. In this video, you see the turn and forward roll exercise using a virtual version of the app, which lets us adjust parameters like length, spacing, width, and cone height. This setup helps us collaborate with rehabilitation researchers to redefine the training experience. In the third phase, we are turning the virtual exercises of the second phase into an actual game. Here we drew on key insights for game design from a motivational analysis of physical therapy by Aufheimer, stating insights such as involving therapists in the process, allowing flexible setups, leveraging autonomy in games, and designing feedback on success rather than failure. We created a Caribbean-themed island where players can freely explore as they move around the island. They encounter characters who offer missions. Each mission is a short minigame based on a specific wheelchair skill. The virtual wheelchair is controlled by an actual hardware of the children's wheelchair, allowing them to use the input peripherals as they would with their own wheelchairs. Therapists can use a companion app to set the difficulty and number of repetitions for each mission. Once a mission is completed, the player goes back to free exploration, ready for the next task. After we have a working prototype, we wanted to understand how it actually worked in practice. So we asked ourselves, what is the practical experience of children and their therapists with RollAbility, and what potential do clinical experts perceive? We started by running a session with 5 clinical experts. They went through a training session guided by a rehabilitation researcher as therapist and gave us feedback that helped shape our evaluation framework. Instead of using the wheelchair controls, we replicated the wheelchair joystick with an Xbox controller positioned on a flat table. Then we tested the game with 6 children and teens who have complex movement disorders. Each of them used their own powered wheelchair to control the game. Their regular training therapist observed the sessions, while a rehabilitation researcher guided the training. After the sessions, we interviewed the clinicians, the children and teens, and their therapist to evaluate their experience of the game. We used open-ended questions inspired by the Player Experience Inventory, or PXI, to guide our evaluation. These questions explore two key dimensions of player experience. First, we look at the functional aspects of gameplay, such as how easy the controls were to use, whether the goals and rules were clear, how challenging the game felt, the quality of progress feedback, and the overall audiovisual appeal. Then we turn to the emotional experience. We asked whether the game felt meaningful, whether it sparked curiosity, if players felt a sense of mastery over their skills, how immersed they were during play, and whether they experienced a sense of autonomy. During the interviews, we recorded the answers, and afterwards the research team carefully transcribed the recordings. We analyzed these transcriptions using a thematic analysis approach, employing a deductive coding method. In this coding process, we again utilized the 10 key topics from the PSI theory as our primary themes. This analysis resulted in the following findings. Overall, the feedback was very positive. The kids and teens liked using their own wheelchair controls and really enjoyed the game's visual and sound design. Therapists noticed that the way players drove in the game closely related to how they drove in real life. They also saw higher engagement compared to traditional therapy. And experts saw value in the potential of shielding immersed players from real-world distractions. That said, we also encountered some notable challenges. While therapist involvement was clearly beneficial for accessibility and support, it occasionally limited the player's sense of autonomy. Another issue was the absence of failure in the game. Since we intentionally designed the experience to avoid negative feedback, players had fewer chances to learn from their mistakes or take meaningful risks, or were confused by the lack of feedback when doing something wrong. In therapy, games are often suggested to boost autonomy, but our research shows that therapist involvement can limit this autonomy due to the necessary moderation and constraints of training therapy. A detailed model of player autonomy called Integrated Model of Contextual Autonomy Support in Leisure Play Context by Turning suggests that true autonomy in gaming involves freedom in choosing when to play, what to play, and how to play, without any real-world pressures. However, RollAbility offers limited autonomy according to this principle, as the game adheres to strict training schedules, enforces specific game selection, it prioritizes clinical performance over personal playstyle, and its success hinges on real-world skill transfer. This raises the question, can games truly enhance autonomy in traditional therapy settings? Further exploration is needed with the HCI community to understand player autonomy in serious settings and the potential of games to meet psychological needs. Thank you for your attention. If you have any questions, you can email me at douwe.ravers@keileuven.be.